We've been practicing using the quadratic formula to solve quadratics, and we know how to factor, but we've been using quadratic formula. And one of the things that we should be able to do is look at an equation and determine the number of solutions that it's going to have. And what really helps us with this is this part of the quadratic formula right in here. This is called the discriminant, and we use it to discriminate between the different types of solutions that we get. So taking a look at this discriminant, there are times when it equals a perfect square. So like, let's say it ended up equaling 25. So if that were to happen, I would have some value plus or minus the square root of 25 over some value. And notice that square root of 25, I can calculate that. That's just plus or minus 5. And if this happens, what's going to happen is I'm going to get two answers because it's plus or minus, and my two answers will be rational because I can just resolve them as a fraction. So one of the things that I know is if my discriminant, if it's a perfect square, I'm going to get two rational answers. So that's one thing that I know right away. Let's say it's a non-perfect square. Let's say I took my b squared minus 4ac and it didn't equal 25. Let's have it equal a different value. Let's have it equal 27. So now it's equal to a positive number, but it's a non-perfect square. And now if I have square root of 27 in here, hopefully you can see that, it's no longer going to be plus or minus 5. It's not going to be something I could easily evaluate. It's going to have some decimal expansion that lasts forever. So actually, I won't be able to get to that next step. This right here will just stay at 27. And I'll leave my answers in terms of plus or minus square root of 27. So I still have two answers, but what I want you to notice is they're irrational. Like square root of 27 is irrational. We won't even worry about reducing it right now. We'll just do it. So if I get a non-perfect non-square, I'll say, but it's still positive, I get two irrational solutions. Let's see what else could happen with this. It could happen instead of it being 27 or something like that, a perfect square or a non-perfect square. What if it ends up being 0? Like it could. We'll do this one. It could end up just being a 0. So notice it would be negative b plus or minus square root of 0 over 2a. That's 0 is square root of 0 is 0. So that would just end up being negative b plus or minus 0 over 2a. And notice the plus or minus 0 doesn't really matter. It's negative b plus 0, negative b minus 0. So you just get one solution. That happens twice actually. It has like a multiplicity of 2. But if it's 0, what happens is we only get one answer, and it's a rational answer. And then now there's just one other case that I want to talk about, and that is when this square root ends up, let's say we've already done perfect squares, positive numbers. We've already done non-squares, positive numbers. We've already done 0. So what if it ends up being negative? What if it ends up being something like negative 7 or something like that? So square root of negative 7. So if I go to square root negative 7, I don't get a real answer for that. There's actually no real number that gives me square root of negative 7. That negative 7 gives me, I should say. So I could say that there's no real solution. There are solutions. They're imaginary, but for now we'll just say no real. So if it's negative, I will get no real solution. And just to preview a little bit, we will talk about what you don't get any real solution, But what you do get is two imaginary solutions. And that'll be part of this topic, talking about what that means.